In this video, we will be describing the types of finite element analysis performed for the landing gear of the production aircraft built for the design, build, and fly competition. It is crucial to have a strong landing gear to safely support the plane for takeoff and, more importantly, its return to the runway for landing. The three main tests that were performed was a static, modal, and buckling analysis. To simplify the analyses, the fuselage of the aircraft was suppressed due to the complex geometry and issues with the mesh function during simulations. For the static test, there are two main cases that may cause the landing gear to fail. Since the axle that holds the wheels together is relatively thin, the material used will be critical in determining whether failure will occur or not. In the first case, both wheels will experience an even load of 17.5 newtons of upward force, creating a bending stress close to the joint with the balsa legs. In the second case, an upward force of 35 newtons will be applied to only one side of the wheel to simulate an uneven landing. To summarize the results, the rod was chosen to be made out of aluminum due to its low density property. However, we found that using aluminum will ensure yielding or failure during either cases due to the high bending stress experienced from the landing. Through this simulation, an iteration was made and a new material, which is 2 times lighter than aluminum, was chosen for the axle, carbon fiber. In the modal analysis, this simulation was used to imitate the landing gear rolling on a rough runway. However, this simulation was not as relevant to our goals because this plane will be used on a smooth runway without much vibrations to allow such frequencies to occur. But the significance of this result will help determine whether to stiffen or dampen the design to change the chances of creating these particular mode shapes that may cause failure. Lastly, our buckling analysis was performed to further analyze whether or not the spokes in the wheels will buckle due to thin geometry, but the simulation results show that this will surely not occur since the factor of safety was very high. This means that we can reduce the material of the spokes and in turn create a lighter, desirable aircraft. In conclusion, it is very important to perform finite element analyses because it can help save time and material costs during production. Thank you.